Hi there, Chemistry 11, just continuing the lab that I had to quit from earlier. So here's where we were at. There were some very stubborn crystals of copper sulfate that just weren't dissolving for me. So I let it sit for a while and entropy did it for me. They're all in solution, so we're good to go. Now I need to be careful, of course, because I want to bring this up to the exact fill mark and not above. If I bring it above, in this whole video I'm making, I'm going to have to film it again, and I don't want to do that. So far, so good. Now, of course, source of error. I can't just set this aside as it is. It still has copper sulfate in it, so I'm going to use a squirt bottle. I'm going to rinse the sides. And I'm also, as I do this, I'm getting any that might be left over at the sides of the funnel. Hoping to get at least one more wash like this. Again, wanting to make sure I don't overshoot that level. I think 3 rinses is good enough for this beaker. I'm going to give this one more bit of a squirt here. One thing to worry about is that the end part, the top part of a volumetric flask is narrow. And so that shoots up really quickly. Also, it's going to keep flowing for a moment. If I'm using a funnel, it's going to keep flowing for a moment after I'm done squirting. And I don't want to make this video again. The next thing I'm going to do, so I don't have to make this video again, is I'm going to add water with a pipette. So I'm going to get this funnel out of the way. I'm going to put water in a pipette and I'm going to add it drop by drop. First of all, I shake the edges to make sure that I'm bringing down any water that's already actually made it in here. And now I want to be level with the line. One more drop. That's it. You can't see it, probably, but I can. And I can tell you that the bottom of the meniscus is exactly level with the fill line, meaning that in here, the contents of this, the solution that's in here has a volume of 100 milliliters down to certainly 3 significant digits. So as you can see, what I'm doing now is I'm able to, with the stopper, mix this a little bit. Homogenizing it, because now I'm going to use it for taking this solution and I'm going to make a, this is my stock solution, and I'm going to make a 0.10 molar solution, right? Because this is 0.50 molar, and I want to make 0.10 molar. So I'm going to need to take some of this, and it will go into here. Also, I will want to top the rest up with water. So here we go. And here's where you need to do some calculation. Part of your write-up for the molarity and dilution assignment is to tell me how much of the copper copper sulfate it is that I need to add to this and top up with water to get a 0.10 molar solution. This is 0.50. I want a 0.1 molar solution. How much of this will need to go into here where the rest is filled up with water to dilute it to get that 0.1 molar solution? So I'm not going to show you. But that being said, there's probably a bunch of you out there who can do this with mental math. I'm going to use a funnel again. This contained my copper sulfate. I've transferred it into here. I will be topping up the rest with water, and I will get 100 milliliters of a 0.10 molar solution. Of course, some copper sulfate is left over into here, so I'm going to do a rinse. In fact, I'm going to do 3 rinses. I want to minimize the loss of copper sulfate in any container that has it somewhere along the way. Then I need to also be sure that I'm bringing this up to that exact fill line again to get my more dilute solution. One more rinse of the graduated cylinder. By the way, when you do Chemistry 12, and a bunch of you will, I'm sure of it, you're going to be not using these. Well, you'll use these some, but you'll also get used to using a piece of glassware called a burette. Burettes are very useful because they allow you to measure volumes with a higher level of accuracy than a graduated cylinder does. Thing with burettes, you're welcome to have a look at what it looks like on YouTube for titration, is that they are a whole lot of work to set up, and they're a whole lot of work to clean up from. And stop. Bit more. There. Good. So again, I don't want to overshoot, because if I overshoot, I need to start again. So we use the pipette. You may notice that the fill line for this volumetric flask is higher than the fill line for the other one. I don't know how they're manufactured, but clearly they're manufactured in a way that they figure out the volume the volume kind of takes precedence over the shape, I guess is what I'm trying to say, or takes precedence over the location of the line. They just figure out what volume it takes to get to 100 milliliters and they put the line there, which also implies that they have some kind of standard 100 milliliter amount. Done. So note this. This is the original stock solution, 0.50 molar copper sulfate. And this is the experimental solution, 0.10 molar copper sulfate. I made this by diluting from this. You can use your equations about C1 and B1, C2 and B2 to calculate the amount I had to add. That being said, some of you might be able to do this using mental math. I hope that helps, and that is all you need to know now for the molarity and dilution worksheet and lab.